Hello, everyone, and welcome to our 104th AIM Sports Learn Fast webinar. This is the 30th of 2001. We've been doing these since March of 2020 and been having a great time putting all of these together. Much thanks to all of our co-hosts and all of the AIM staff that help do these things. I sit here and talk a lot, but but there's a lot of work is being done in the background, and all of that is much appreciated. And I hope all of you that are watching this either live here on Tuesday morning, afternoon, depending on what part of the world you're in, or watching it on YouTube later. Certainly appreciate you being here, and hopefully you're thankful to all those other people that are taking care of a lot of things. We're going to talk a lot today about, we're going to take some live questions from the folks that are here live. We're going to be putting some, you'll hear us talk about putting some links into the chat box. Anything we talk that way, if you're watching this later on YouTube, if you go down to the description box, it often is collapsed. It'll say show more or something like that. Click on that. It'll open up that box, and all of the links that we're going to talk about will be down in that YouTube description box. Today we're going to share not only the presentation, but we're also going to share the data that we're going to look at live in Race Studio 2. We're going to share the profiles to set up your screen to look the same way that Chloe is going to show us how to use, and the math channels that she's going to talk about are all going to be shared in the chat box live here today, and also of course in the YouTube description box below. So you can download this data and videos. No video today. The data, the profiles, and the math channels to take a look at this data in the same way if you wish. If you're learning how to do data analysis and want to try to put into effect some of the stuff that Chloe's going to talk about today. Okay, perfect. So let's go ahead and get started. Again, welcome everybody. This is Chloe's second time of joining us. So I just took the cheap and easy way out, motorcycle racing data version 2, and we had a lot of really good response from folks that watched Chloe's first one, where she came in and chatted about kind of a basic talk about motorcycles and putting a solo on a bike and what you could get out of that. And she showed a couple of data analysis techniques that she uses. We'll get into her background here in just a moment, but had such good feedback from that it was we obviously wanted to invite her back, and here she is. We're going to talk about version 2, where we're going to add a little bit, not a ton. We're going to look at data maybe in a different way, and we're already planning on having Chloe back for maybe certainly version 3 and certainly version 4 after that, where we just keep adding more and more complexity to the data on the motorcycles. So looking forward to that. A little bit about Chloe, I'll let her chat a little bit about it, but the couple of main things to me that are interesting is she's a racing data engineer, a working racing data engineer at MotoAmerica while running a regular job. She'll talk a little bit about that probably, but she's also a racer. She's out there riding her bike on tracks and having a good time. Club racer number 147. It's her second time being here. She has her master's degree in mechanical engineering, so it's chatting with her is always a struggle for me. I have to work hard to keep up, and but it's always fun. So Chloe, I appreciate you coming back. Everybody's looking forward to hearing what you have to say today. Give us a little bit more background on you, and anything else you might want to chat about yourself.
All right. Well, hi everybody. It's really nice to be back. I think I'm a lot less nervous than I was last time, so it's gonna be enjoyable. You've covered a lot already, but yeah. So I am from France initially, and I came over to the US for my master's degree and an internship before that. And so I got my master's in mechanical engineering from Wisconsin-Madison, which has an engine research center lab, which is pretty well known in terms of engine research. And then I've been working on small engines when I was in grad school, and I've been working on like medium duty and heavy duty engine research since then. So I worked a little bit at Cummins, and now I work at Oak Ridge National Lab doing heavy duty engine research, looking at a lot of Frankenstein engines on working on dyno. So I work on natural gas conversions. We're looking at potentially methanol, stuff like that. So really looking at efficiency and emissions on those big engines, and maybe stray away from diesel.
Yeah, it's interesting that your hobby, being a motorcycle racer, uses an engine about this big, and your work is engines bigger than my garage, right? So
right.
yeah.
And our engine dyno cell is gigantic.
As big as your house, right?
We actually have two 13-liter engine attached to it, so it's pretty interesting.
Wow.
But
wow.
yeah, and about 3 years ago, when I got my first job, I started doing track days, got involved into motorcycle track day coaching about a year ago. And it's really a lack of communication or lack of vocabulary that pushed me to start data analysis. I just got this Solo 2 because I could not really explain what I was feeling. I didn't have the right terms, so I just started doing it on my own and just looking at my own data. And here we are now. I'm just working at, it's my first full season at MotoAmerica. I started last year and did a couple rounds. But yeah, we're halfway through the season and doing pretty well. So
yes, you are. Pretty exciting to be able to travel around and work at something that you love doing. I'm glad to hear you're doing it, and I'm glad that we're working with you and maybe giving you even a few more tools in the toolbox as you head out to do the job. So
absolutely.
Perfect. Okay, let's step up. We've got maybe 3 or 4 slides that we're gonna look at. Today's the bulk of our presentation today is going to be in live data. So, but we do have the presentation that's available. It's probably been linked over there in the chat box. If not, it will be, and it's also linked down below. But first thing, Chloe, as we go to get started, give us since what we're doing with you is kind of building. And we'll have a link in the description box below where you can go back and watch her first webinar, and we're going to build on those. Chloe, give us just a little bit of a background on what you chatted about in your first presentation.
Yeah. So last time we really focused on the Solo 2, which is probably one of the most common lap timer that people use on the track day scene. And really the point I was trying to make with the first presentation was the Solo 2 is not just a lap timer. There's a lot of data that we can look at, and a lot of data that we can derive from all of those GPS channels that we get. But the Solo 2 is really only a GPS, and it has a gyroscope in, so it doesn't log any analog channels. It doesn't log anything that's coming from the ECU. It's a standalone box. But I just really wanted to focus on what can you do with it, and we can do a lot. We can, focus on the GPS speed, but then from the accelerometer we can derive the acceleration and the braking, and sort of make some assumptions on how the bike is reacting. But let's say you're starting racing, you really want to dive into how your motorcycle modes are set up. If you have a motorcycle that's using a lot of CAN bus data, or you have something that's fairly new, and there is like a rain mode, a sports mode, a bunch of different things. How can you monitor that? How can you go a step further without really having to have the full setup with brake pressure sensors and potentiometers and all that? And that step would be going up to what we call the Solo 2 DL for data logging, or any of the dash, really any of the dashes like the MXM, MXL2, the MXK10, which is a plug-and-play system for the ZX10, or like the top of the line, which is the MXS 1.2.
Top of the line. What you've listed here is what's really super popular in the motorcycle world. A lot of packaging issues there, obviously, but all of our AIM devices that are above the Solo 2 DL, all of our dash loggers and our black boxes, the Evo 5. I know some of your users have that on there too. All of them will do what you're talking about as well.
Absolutely. And some of them will have the ability to log more channels, like we'll have the harness for the analog and digital channels, which the Solo 2 DL won't have specifically, but it's a good step up. So the two pictures are showing. So the one on the left is my bike and the way I set up my Solo 2 DL. And then on the right side is Nolan Lemkins that who I mentioned before, who shared all of his data. And that's his GS dash that he has connected with an Evo 5.
And I think Noah has a link where he shares a lot of data, and I think we'll either have that linked in our chat, or we'll certainly link it into the data.
Right. So Nolan
Lemkin
Racing, he has the entire build for his R6, and he has all of his data that you can download.
Very nice. Well. Yeah, very handy for people that are just learning and want to learn a little bit more about it. And much thanks to him.
Right, it's been really helpful.
Okay, let's go to the next slide. There we go.
And so on the next slide, I have some example of additional data that you can get from the CAN. So if you were not really convinced already that it's really interesting to look at what's going through your CAN bus, I took the most common motorcycles, so ZX10, the newer R6, so 17 and above, and then J6R 1000. And so you can log stuff like your RPM, your grip position, and your throttle position, which are really interesting because the grip position is how we're moving your hand, while your throttle position is actually how the throttle is moving. And when you have a ride-by-wire system, you can tune the throttle position, and we'll get into that. Coolant intake temperatures, the air-fuel ratio, the GSXR has that ability. You can get your gear position right away. It also logs which modes you're in. The GSXR also has the ignition angle, which is really interesting. So ignition advance. And then modes like traction control, wheelie control are logged in. A really interesting data set is the wheel speed, front and rear. The rear wheel driven distance, which is pretty interesting to correlate with GPS speed. And then those newer bikes have an IMU, so you can get the lean angle that is measured or calculated in the IMU, which we'll have a discussion about that, since last time we were talking about the variation between the lean angle channel in AIM and what the actual IMU could measure.
And of course, this list is not exhaustive. There is many more channels. It's just you put together a list of some of the stuff that you like to use all the time and that is common across a lot of different ECU protocols.
Right, absolutely. And different bikes are going to have different sets of data. It's important to note that this is going to be for all the bikes that have a CAN bus. For example, I have a 2008 R6. And the communication protocol for the R6 is called the K-line, and I don't have all of that. I just have RPM, which is still really interesting because you can get the gear position or the gear changes from the RPM, and I have a couple temperatures, and that's about it. But yeah, the more recent the bike, the more channels you're likely going to have.
Yeah, these ECU protocols and our availability to get those, it was really based on just diagnostic things, right? For the bike manufacturers to be able and dealers to plug in. And 2000 and older than 2006 or 7, it truly was just diagnostic. Sometimes it was really slow, and as that has gotten better and better, we're able to grab more and more of it. So anything that's newer, we're probably pretty good with. Some of the stuff that is older, it's hit and miss a little bit, or the sampling rate is quite slow. But there is most of the new stuff we're pretty darn good with. So.
Right, and that's also a good point. There is going to be, depending on the level of data analysis that you want to conduct, the frequency or the frequency of data acquisition can be a limiting factor. And so in some instances, people would rather add an external sensor instead of reading the CAN. But I think for the level of what that we're targeting this time is going to be track day people and club racers. In that case, that's more than enough.
And maybe when we jump into your data, the live data in a little bit, we'll right click on the channel and we'll show folks where to go look and see what that data sampling rate was. So you can, good data, data is data, and there's good data and there's bad data as always. And so it'll let's give them a little bit of a tip on how to figure out what they're getting. I did have a question that just showed up in the the question and answer that I thought it was only one slide back. Let's bring it up and chat about it, because bikes do this a lot because of just packaging reasons. Andy is asking the question: your aim device is mounted at an angle, right? And not only laid down a little bit, but rotated a little bit. Do you have and use internal accelerometers, or just the GPS derived accelerometers?
No, so that was a conversation I think we had
A little
when
bit in the
we did
first
the
one,
Solo 2. Yeah, it's really complicated for a motorcycle to have your Solo 2 flat or not flat, but vertical with the GPS antenna pointing up. Everything that I'm using is, and for myself, I'm really using my own data. So I'm just comparing, my data against my data. And so the Solo 2 doesn't move. But yeah, I'm only using the GPS and the accelerometer that's in the Solo.
And the GPS based ones are give you some really good stuff, but also on the bike, those of us that are mainly around cars, we would look at that and go, okay, there's a constant there that maybe we could correct for. But with the bikes, you're leaning it over and you're moving it back and forth. So even if you had the Solo mounted perfectly, things are moving anyway. So it's so there are things you need to work around with that.
Right.
So,
and it's a really good point that we need to only consider lean angle data as a relative value and not so much as an absolute value. So meaning that the number is not going to mean anything. However, the differences between my own sessions is going to be indicative of my lean angle. But yeah, I wouldn't take the number thinking like, oh, I'm doing 60 degree lean angle. That's probably wrong.
But you are working behind the scenes, and maybe I'm stepping outside of the box that I should be stepping. But you have mentioned to me that you're pretty smart engineering background. You're working on some things to maybe do a calculation based on using a bunch of different things to get that to be correct. Maybe something we can talk about down the road.
Right.
Okay, let's jump back. Let's jump back up to this is really our last slide we're going to chat about, and it's really just kind of setting up a discussion. We're going to have a discussion here on what's kind of important to you. We're going to use Race Studio 3 here as the background, but it's the squiggly lines and how you're packaging them is what we're talking about. We'll look at it in Race Studio 2. This is kind of a home base for you, right? What are we looking at here, and what's kind of important to you and your normal data analysis?
Right. So here, what I want to focus on is looking at how the data can inform us on about the strategy that the bike is using. So I built this window specifically for the ZX10, where I'm looking at, so the top window, we're going to look at all the speeds. So I have the GPS speed, the front wheel speed, and the rear wheel speed. Then I'm looking at, I want information on gearing. So I'm looking at the RPM and then the gear shifting. Then what I think is extremely interesting, and probably the channel that we use the most, is the throttle position. So it's throttle position as grip position versus, or grip position and throttle plate. And then I have the engine strategy. So on RS2, I actually have two separate windows for that. So we're going to look at how the wheelie control works and how the traction control works. And it's going to be really interesting to see where the bike is sliding, where the bike is wheeling, and try to see as a function of different traction control modes, for example, like how the bike is actually reacting. So it's really good to have those logs. And then the last one is the lean angle. And on RS3, I wasn't able to put the lean angle from AIM, the lean angle calculation, but this is the lean angle from the IMU.
And for those of you that are watching here live or later in YouTube, some very specific motorcycle things we're going to talk about, which is great, and you'll enjoy it. But for those of you that are watching now or watching later, just the concepts of how she is doing different things. Yeah, we're going to look at a lean angle that you may not have in your sports car or your off-road vehicle or whatever it is that you happen to be looking at data on. But just the approach she takes and the steps that she follows are great learning tools for all of us to learn more about how to analyze our own data, even if we don't have an engine strategy set of channels. It'll be fun to learn a lot of different things from Chloé here today. Anything else you'd like to add about that before I stop sharing and head over to your screen?
So just no, so RS3 has some really good features that that I like to use. I really like the fact that the map stays in the corner, and we can actually turn the map. Maybe we could show that in the RS3,
Yeah.
where you can turn on the GPS background on it. So it's really cool because we can actually see the boundaries of the track and really see where the line is on the track. I also really like the way the channels are not filtered, but they're organized, and they're organized by types of channels. So whether they are math channels or GPS channels, etc. So this is a bit, I think for today, we're really going to focus on RS2, which is the production software.
And Chloé is getting up to speed and learning as she goes. Obviously, with Race Studio 3, it's a beta piece of software, and so she's out there in production, working with teams, and so she's kind of sticking with Race Studio 2. So we're going to probably do that as well. And good clarity here. The only thing that really held us back from maybe doing this in Race Studio 3, just as a good example, is the math channel functionality in Race Studio 3 is not quite there yet. It's one of the last things they're working on, and some of the stuff she wanted to show today with math channels was maybe could have fought us. So it was just better to use what she's using and what is production in our AIM world. So that's what we're going to do. Probably at the end of the presentation, depending on how much time we have left, we'll come back and show, maybe she'll show her screen with some Race Studio 3 stuff in it to give everybody an idea of kind of how she sets that up too.
Okay. And we have an interesting question on whether I use a derivative of lean angle to see the speed of like the rate of change of direction. I don't have a specific channel that calculates the derivative for the lean angle, but you can definitely see it if you draw like a zero line. You can definitely see how steep the curve is. So you can definitely see how fast of a direction change you have. For example, here on that screen, you can see towards the end, there's a very, very steep and that's probably, I believe this is the corkscrew.
Yeah, no doubt. Chloé is still learning, some of those deeper pieces of what we do. And if we have some time again, I will take over, bring up some of her motorcycle data, and we'll build a derivative channel really quick out of the lean angle channel and show you how quick it is to build it, and maybe even look at this if we have a couple of minutes right at the end. So some of our functions in Race Studio 2 math channels are very, very easy to build. The only reason it kind of stuck in my head when the question was there is I had two users contact with me over just the course of over the weekend asking for derivative of suspension positions, and I had to type up some good directions on how to do it and explain it for everybody, so I can do it pretty quickly here today.
Yeah, I've actually done it for suspension. That's you're making a good point. There's a really good
very
function
fast
that's integrated.
Very fast. So yep, we can do that pretty easily. Okay, then Chloé, I am ready to stop sharing mine. If you want to share your screen, let me. Okay. If you're ready, let's stop sharing this. We'll go to full size for a moment, and then you'll share yours.
All right, let's do this one.
We decided to run the software on her end, on the guest's end today, and I think we'll enjoy doing that.
Can you see my screen?
We can. We are off and running.
All right. I want to try to bring up. Can you see the track map on it?
It's just off to the left edge. So there you go. Now it's in the spot.
Yep. Okay, there's a little bit of a delay, so I'll try to be mindful of that. All right. So like I was saying, here is it's RS Studio 2 or Race Studio 2. And we're having the same channels that I was just mentioning. And I will put the measures right here. Okay, so we have the GPS speed, which is here in green. We're looking at the speed of the rear wheel in pink and the speed of the front wheel in purple. Can everybody see the purple pretty clearly?
It is a little bit dark, but it's not bad. We can see it a little bit. Yeah. If you want to change it, show how easy that is to do.
We'll put it in blue. All right, and then we're looking at the gear position as well as the RPM in the second window. Then third window, we're looking at the TPS, so throttle, actual throttle plate position, and then the grip position in green. fourth window, I have the wheelie control and the wheelie angle. So we can see the wheelie control is an on and off. It's a switch basically mode, and then we have the wheelie angle that's measured or calculated based on the IMU. We have then the traction control, which is also on and off, and then we have in green the wheel speed difference. And this is a math channel that I've calculated that I've put in. And then at the end, we have the lean angle that I calculated with the aim function, and then the lean angle from the IMU. So really in this, the only two calculated channels or math channels that I have are the wheel speed difference and the lean angle. Everything else is coming from the ECU. So that's how powerful, CAN bus data really can be.
Yeah, and just so just to catch everybody up real quickly, this data is available for you if you want to look at it later. The links have probably already been placed into the chat box. If not, there'll be this file and a second comparative one, or we'll look at in just a moment. It's Laguna Seca data, and it'll be in the description box down below where you can download this later if you're watching it afterwards, including the profiles and the math channel she's using as well. Okay, now let's dig in a little bit deeper.
Yeah, so I see two questions. Should we address them now?
Yeah.
Okay, so the first question is, what's your primary trace to inform you of the confidence a rider has on the bike? And I would say generally the main things we're going to look at is the throttle, is how much full throttle the rider has, and how fast he's able to accelerate. This rider does not have a brake pressure sensor. So if I wanted to look at how hard is braking, I would have to bring in the brake G calculation that I had that I mentioned last time in the first webinar. But usually throttle and brake is what we're going to look at, and how fast those transitions are, how much cruising is going to have, and the cruising is usually the that little delay between when you're off the throttle and when you're on the brake. And what's really interesting, last time I shared data from a twins bike, and you could see that the throttle position was really almost a square wave. There was a lot of time at full throttle. And we were also looking at MotoAmerica, I think, which has really, really, really long straights. Here we're looking at Laguna, and we're looking at this a 1000cc bike that has a lot of power. I actually don't even know the horsepower number, but it's really close to probably 190, something like that. And he does not spend a lot of time at full throttle because really he can't.
Yeah, amazing.
It's really fast. Yeah, and Laguna is a pretty tight track, anyways. So, and then the second question: does 1G lateral always work out to 45-degree lean angle, assuming a flat track? That's a good question. I don't know. I wouldn't assume so. I don't have data from a flat track, so it's really
my guess is I think there would be so much in the engineering of the bike, right, and the tire and all of that. My guess is I don't think you could mentally, as you just roll that through, that seems like a convenient way of looking at it, but I don't think that's true. I think that the lean angle will vary. And
the function that describes the tire is not quite linear, so I wouldn't say so.
Yeah. Okay. Perfect.
So diving into it, the first thing that really shocked me, and we actually talked about it yesterday, and I have additional answers on that, is how completely off the rear wheel sensor actually is, the rear wheel speed.
The speed resulting from the sensor, yes.
Right. And so I did a little bit of digging on that yesterday. It's actually not an offset or anything. It's really that the calculation within the ECU does not correct for lean angle. So here we're only there's only an input for what the tire that is unloaded and straight, what the perimeter of the tire is, the circumference of the tire, and it's basically just multiplying that by the wheel speed, and you can actually see how much it affects it. So you can see that whenever the bike is fully vertical, which is really not that many in that many instances.
Yeah, really, they're like 4,500 feet. There's a spot there that the purple is right on top.
Right, so right here.
There's a good spot, right? Yeah. it matches fairly well, but the
matching fairly well. And then the bigger difference is really when we have the most lean angle.
okay.
And that is clearly the change in radius as the bike moves. And sort of what really hinted me to that is that the front wheel does not have that big of a difference, because the front wheel tire is not as big. So the difference in change of radius is actually not going to be that drastic. However, when you're fully lean, there is quite a bit of a difference. So that was the very first indication of, I wonder how the traction control works. And I wonder if the traction control strategy could be affected by the fact that the wheel speed is wrong, or wrong is just not corrected for what we want. And it's actually something that I mentioned to Chris Lessing, who's also working with the ZX10 at MotoAmerica in a Superbike team or Stock 1000 team. And he mentioned that the 2019 ZX10 does not make that the correction. So there, and the traction control is almost only based on wheel speed difference. So this calculation that I have in window 1, 2, 3, 4, 5 is the rear wheel minus the front wheel speed. And you can see that when I'm crossing, it's about 20.
At the peaks, yeah.
At the peaks here, I have the traction control coming on, except in some areas, which indicates that there is probably something else that goes into the strategy, which is probably going to be either RPM or throttle position or something like that. And whenever I have this the speed difference, in most cases, I have the traction control coming on. And I was talking with the rider, and he likes the way it is set up. But he was wondering how intrusive it was, and he was wondering really how, like, what it was based on. So now we know from the data and from the CAN data, we know that we know how our traction control works, and we know that it's based on the signal, and it's actually not absolutely accurate, I want to say.
Yeah, it's always interesting how data can answer so many questions, and then and then our mindset is learning from the data that we have, and then that we get to a point of James Coburn talks about it a lot. You know, this data process, this data learning process, and then we get to the point where, okay, we know what we know, and now we know we don't know as much as we think we know, and then it's something like this. All of a sudden, now it created more questions for you. A bunch of information created more questions. You went out and resolved them, and now you've got that, and we're moving forward, and just continuous improvement of your data analysis and your help to the team. It's a great thing.
Right, and it's kind of surprising to me that Kawasaki has not come with a correction for that, because they do have the lean angle position. So my next step is going to be, and I didn't have time to do that yesterday, but I want to correct for that lean angle, since we have the lean angle data, and the shape of the tire is actually just a simple quadratic function that I have and I could share. So it's pretty easy.
A
to
simple quadratic function. That
So
I think there's a definition problem. But let me just add. No reason for us to go into this deeply, but I remember the first time I looked at road racing motorcycle data, and I went to the track many years ago, and I was just helping somebody out that had called, and I looked at the data, and as the bike was being stood up coming off of the corner, of course the tire, you mentioned it earlier, the tire when you're on the sidewall is overall shorter, right? The circumference is shorter. And so which is what we're seeing here. And as you stood the bike up, I thought there was a problem. It only took a few minutes to figure it out in my mind, but the rider was at full throttle coming off the corner. The speed was going up and the RPM was coming down. And it was a very, very odd thing at first. And it didn't take too long to figure out that, okay, well, there's some oddness that's happening here compared to what I was used to as sports cars or off-road trucks or whatever the data I had done at the time. So it's just part of motorcycle racing, and you figure it out fairly quickly, and you just work with it, and it's just a known thing.
Right, and then you can account for that, but then you also have to account for tire deformation. So I don't think I will ever get to matching perfectly, and I can follow up on that. It's going to be really interesting, but I don't think I can get to matching the rear wheel fully to the GPS speed, just because when I'm done correcting for lean angle, which I've already done on the side with Excel data, I'm still going to have the deformation of the tire due to the load on it. And I have two sets of data that I'm looking at. The first one is from the Twins bike, and the other one is from the ZX10. On the Twins bike, again, get pretty close because it's not that powerful of a bike. The deformation on the tires are not that hard. However, on this data, I can't even come close if I don't have the force of the tire, so the force on the tire. And then that's a rabbit hole on that you can chase on how you can correct for that, how you can account for the force on the tire if you don't have potentiometers or anything. So.
Yeah, it's an engineering exercise. Let me tell a couple of quick little things, but the deformation that you just talked about, but also, and Emiliano mentioned it as well, is there the faster you go, the tire grows on top of it, right? So there's deformation on when it's loaded, and when you have it stood up and you're going, the tire grows on top of it. So there's that would need to be modeled, and that's different for every situation, I suppose. Anybody that's put a car on a chassis dyno, a lot of car folks here too. And you strap that thing down and you fire up the chassis dyno and you take that thing up to 120 miles an hour or whatever on the drive axle, and the car is lifting up, and it's the you can see that always in the data. It's not quite like Top Fuel dragster tires, but there is a growth there that happens all the time. So it just a little beyond what we'll talk about here the rest of the day, but it's an interesting factor that all of us run into.
And it's also really interesting when somebody says, my R6 can do 180 miles an hour. Well, probably not. What you're seeing on your dash is probably wrong, because it's based on wheel speed most of the time.
The GPS numbers, though, if they're using that, then it becomes a little bit more accurate, right?
Yes, and that's why GPS is so important. Yeah.
Okay.
So if we keep going on that, then there's some really interesting feature that we see, and I could start zooming on this. At some point, we see that the front wheel is dropping, and is dropping drastically, and that's a wheelie. So we can see that it happens. So if I go back, it happens when the bike is fairly straight up, and it happens at full throttle, and it happens on acceleration. So it's like, oh yeah, my front wheel is actually catching air. It stops turning as fast, and then we see the wheelie angle. So that pink line here that's coming on, so indicating of a wheelie, and then passes a threshold, and then the wheelie control comes on, and we can see that how does the wheelie control actually work? It works by closing the throttle plate. So you can see where I have my cursor here, that I'm just going to move this. You can see that the throttle plate is closing, although his grip is still at about 60% throttle.
Yeah, he's asking for 60, and it's only giving him 45.
Right.
The next interesting, if we go back to that one, I love what the rider did at that point, right? If you look up a little higher, it was doing it. The bike was trying to hold it back, and what was the driver's reaction to it to stop it was, let me just upshift once. You can see right when the middle of that thing, the driver just banged another gear up to also allow more throttle and go. It's kind of the rider's workaround to it on top of it.
Yeah, and I have so a question that says, does it cut the ignition at all? It's a good question. I don't know quite. I was trying to look online to see what the strategies are, but I think they're pretty proprietary. And
certainly not showing it in the RPM data, right? It's
not showing. However, I think that's how the traction control works. The traction control is most likely an ignition cut, because Joey, the rider, was actually telling me that it crackles. So you probably just have all the fuel coming into the exhaust, and then you have a little bit of backfiring. Yep. It could be a little bit of a fuel cut as well, but usually cutting the ignition is so much faster. So whenever you have that traction control, I don't know, you can see like little changes in the RPM, like really subtle changes in the RPM.
Okay, yeah.
So yeah, the ZX10 does not have any information on ignition advance. I believe it's the GSX-R that has it. It would be really interesting to take a GSX-R 1000 data and see the same thing, and see whether we have like ignition advance that just goes to a crazy number, or I don't know if it wouldn't go to 0 because that's an angle, but if it just shuts down whenever there is a wheelie or traction control coming on.
I'd like to focus on, ask you a question to focus on. Now you're looking at this data from your rider, from Laguna, and we see, and I think my mouse will, I'm not sure if it'll come across, you've got your traction control events, the blue lines popping up,
Yep.
and you can see that those are always happening. They always happen when the rise in the rear wheel speed is coming up. That green line is coming up to meet it. Is that an area that you could use to help the driver get a little bit better? If we look back about the 4,000 foot range, you see one there where it's actually rising, but it doesn't happen. Maybe the rider, and I'm asking you the question with this type of a question. If that was a little bit steeper, if the rider had gotten to full throttle a little bit quicker, maybe there is some more room for improvement to be a little bit more aggressive on that little straightaway.
Well, we would have to know exactly why it's not coming on. I actually don't really know. That's a question that I had for Chris. He indicated that I should look at the difference in wheel speed in terms of percentage. So it seems like the throttle position is at 100%, and it's at 100%, at the end also when it's coming on. Yeah. And the RPM is about at the same range. So how does the strategy actually work? I don't know. And if I knew that answer, then I could tell him, oh, it seems like you've got
a little bit more room for being a little bit more
room.
Yeah.
It could be due to, I don't know, maybe it's the altitude, where he has more grip. Maybe there's just something that.
But it's certainly going to get your attention. Going to get your attention as a data person,
yeah.
and you're going to look into it and try to help the rider, if he can be more aggressive there, be more aggressive.
The idea is like, you're potentially not sliding enough here. Not sliding enough. You're probably not pushing the bike enough here, so you could actually go a little bit further.
Yeah. Interesting.
Yeah. What's actually really interesting here, that completely blows my mind when I look at that data, is that very last section where I have traction control coming on, I have wheelie control coming on. We see the front wheel that's completely dropping, and we see the throttle that's cutting. What's going on here is he's coming out of turn 11, which is the last turn before the straight line at Laguna, and he's sliding and wheeling at the same time, which I don't ride at that level. And to me, that's completely mind blowing. I just don't even imagine how it feels like. But those guys just do slide when they're getting to that turn, just because it's really, really tight. Yeah. And they all train dirt. So they flat track, they dirt track. And they're used to that. They're used to backing it in, like we say. So yeah, this level of riding is so
you see a lot of the bike's electronics are really the rider's really working it, and then the electronics are really kicking in a lot there. That's interesting.
Yeah. So yeah, I guess we could potentially move to the comparison.
Okay.
I see a few questions before.
Okay, let's if the front wheel slows down from wheeling, you showed the front wheel, zoom in on one of those areas, you can see that it is flat. It's maybe more flat than it looks at first, but it certainly is losing a mile an hour or two as it comes up. If it's slowing down from wheeling, how do you compensate your traction control? How do you compensate so your traction control doesn't come on? I think that's part of the strategy of the bikes. I understand how you are activating the rider is not activating the traction control. It's an automated feature.
Right, and the traction control does come on actually. So, could the manufacturer do a better job at actually having some kind of a logic where, if you see a wheelie, or maybe if you see that's just a wheelie, then it's not a slide. I don't know exactly how they could compensate that, because sometimes the bike is definitely sliding, and so they would have to detect an increase in a rate in rear wheel, as well as a big rate in front wheel change to have the traction control. And then if they don't see a big change in the rear wheel strategy, and they just see the drop, then it's just a wheelie and no sliding. That tells me that maybe if I were working at Kawasaki, I would suggest different stuff. Maybe they just don't have the ECU capacity to do that.
But I was surprised as well that the front wheel speed didn't just parallel, right? Didn't just flatline, create a mesa, and then go back up when the front tire touched. Right. But it does go down a little bit, and I don't know if the driver's the rider has his hand resting on the brake, on the handbrake. I do not know, right? So.
Yeah, and Rick is actually asking, could it be that he's using the rear brake? He is certainly using the rear brake in here. A lot of riders won't use the rear brake. I certainly don't touch it at my level, but I know that these guys they will touch the rear brake, and that's also part of the of how you bring a wheelie down. Sometimes you just like press on the rear brake and
there you go.
set the bike down.
Don't just depend on the electronics, but actually a little rider interaction to bring it down as well. Yeah, interesting.
And then he's saying that the traction control could have predictive wheelie built in. Yep. It could do that. And do teams have access to tune the electronic behavior? Yes, we do. It depends. So a conversation that I had this morning is that the 2021 ZX10 does not completely have an open access, and it's usually companies like FlashTune, FTECU, that will work, or Woolwich, that will work on sort of cracking the code or cracking the ECU so they can access it. And then they usually have a set of maps, so they remap the entire bike, kind of reverse engineer it, and so they can import their own flash on it, and then have give full access to that. But as the bikes are going more and more complicated, the control strategy is more and more complicated, and it takes more and more time to have access to all that. So the 2019 ZX10 has a pretty good access to tuning all those strategies. I think for the 2021 right now, they're very limited, and when a bike doesn't have those cracked ECUs, you're really only limited to the modes. So you don't exactly know how the modes are changing. You just know that they have different sensitivity levels.
And they are built to be a balance of what is best for everybody, obviously. And but when you get to the hardcore racers like you're working with, they want to maybe adjust things to make it to get a little bit of an advantage. Right. Racers are kind of built that way, aren't they? So we've looked at one lap of data. You're going to open up now a second lap. It was like a warm up, and then we're going to take a look at a lap from the race. You're going to use a profile where and these have been shared. Go ahead and open up your second session.
And just something that I wanted to bring in here, because I'm going to close this. Here we have little inputs of throttle, and that's just the auto blipper that's intervening in every downshift. So every time there's a downshift, it just rev matches or try to rev match the RPM.
The last thing you want is you're backing a bike into the corner at a high speed as the rear tire to chatter heavily, and the auto blipping is helping keep the rear end calmed down.
Yeah, so we basically went over wheelie control, traction control, and then like the blipping for the gear shifting strategies, which I think is fascinating. So if I bring in, I'm just going to go back to.
While you're doing that, we also shared the profiles, that where we have one profile was set up to be, every channel had its own color and it was all set up in a certain way. When you bring up two laps and have that much detail, it can get a little bit confusing. So Chloe is set up, and we shared a second profile that you'll be able to open up and click on, like she is going to in a moment, and show the data in a slightly different way.
So I have that ZX10R lap compare, all right. So now we're looking at two laps. We're looking at the GPS speed. I've gotten rid of I got rid of my front and rear wheel speed. We now have the RPM and the gear right here. We have the throttle position and not the grip. And then I have when the wheelie control is coming on, the wheelie angle, and then we have the traction control coming on.
And again, you look at it two different ways, because the first one we were kind of engineering the bike and talking about some of the different things. And now we're looking at a warm-up versus a qualifying or a race, whatever it happens to be, qualifying versus a race. And now we want to see where the driver improved, maybe shifted a little bit different, did some things that you had chatted about. And now we're going to compare that data, and you're going to walk us through a lap and talk about what the rider did differently.
Right. And Matt is asking, do bikes axle hop? Like rear axle?
Yeah, I think he's talking about chattering as it comes into a corner. Does that happen sometimes?
Yeah, we do have chattering. We do have we do catch air it happens.
Sadly. You're so hard on the front brakes that rear, the compression on that rear tire is very, very low, right? Or sometimes zero weight. I mean, it's off the ground. I see some of those guys braking so hard that the tire is a couple inches off the ground. It's amazing. Can't hop when it's off the ground, I suppose, right?
Which would be really interesting to look at what's going on when you get onto the corkscrew, because it's so steep, so steep that I don't know.
And you need that rear tire when you lay it over to turn, right? You can't be in the air all the time. So
yeah, there's a feeling of, oh, I'm gonna go over the handlebar.
Yeah, no doubt.
So okay, so coming back, initially I wanted to look at data that had different gearing because he was struggling with his gearing. The transmission that he has is a stock transmission. He's running into the stock 1000 class, running in the stock 1000 class. So what he was trying to do was avoid going down to first gear. So we can see that he has some really long periods where he is in first gear. And so that's going into turn 2 at Laguna, which is an extremely tight hairpin, and all the way to turn 3. He's going back down again in first gear, going into 3, 4, 5. And then he's in first gear again for the corkscrew all the way to, I think it's turn 9, 10. And then in first gear again. So he was using the first gear a whole lot. And the gear ratio for the stock transmission is just not really made to be using it.
Yeah.
I think the new model has a much better transmission for that. But it's a stock 1000 class. He has to run with whatever he has. So so I wanted to do that, but he didn't have the sprocket to make drastic changes. So it's actually not, it didn't specifically make a big change in this data. So here we're looking at qualifying versus race and him trying different things on the same gearing. So we can see that he's trying to keep it in second gear through turn 1, and we see it's not specifically efficient. His RPMs are dropping, his drive out of the corner are dropping, is dropping, but because he's in second gear, he can actually reach, like he can carry it longer. Whenever he's in first gear, he's got a really, really good drive out of the corner, but at some point he's hitting, and it's not close to the rev limiter, but he feels like he has to shift. No, he's not shifting, sorry. He just can't accelerate further. Right there. And so he starts braking. And it's probably him learning the track as well, because that's the first time that he was going there, that he was riding at Laguna. So higher RPM range is usually better, you know, that gives you more of the drive. We can see that, okay, let's see here. He got better approaching turn, what do you say, turn 5, where during the race, he was actually able to carry throttle a lot longer. So he started closing the throttle about the same time, but he was carrying maintenance throttle a little bit longer.
That's a large mile per hour difference there. You know, another little bit ahead from where your cursor is right now. Right. There's a large, so large difference.
We're looking at, we can use the delta function. We're looking at about 135 to 137.
Yeah, just that little part, but he held it all the way underneath the braking the rest of the way.
Right. Yeah. If the cumulative mile per hour is actually really important. Yeah. We can also see. So
looks like almost 3 or 4 tenths of a second of lap time gain from the time compare bar. Yeah.
Right. So so his approach to turn 1 was about the same, but then he really improved during the race in that specific area. And then about the same thing, exiting the corkscrew that following turn. So I think it's 11, it's probably 9, turn 9 at Laguna. Just like carrying
a ton of extra speed there too.
Right, but he was lower in RPM in here, so it's actually really interesting. He decided to just stay in second gear for that ride, and let's see. The pink was the race, and then the blue was the qualifying. So
I know that he didn't want to be in first gear because of the strength of first gear and some other reasons, but the 2 times I see that the rider really aggressively accelerates. It, you know, a little under 2,000 feet, that one spot you showed, the blue lab accelerates substantially
Right here.
better. Yeah, up in the speed trace up higher. And then the other one is at about 9,000 feet, where he's accelerating very hard. And you can see that the blue trace accelerates the speed trace up top. It's substantially better. So if you had some gearing somewhere in between, there would be a second gear that was lower, would be almost optimized, right? Like you said.
Right. Absolutely. Okay. He did go further, faster. Sorry, in during the race, in that pink. So it is due to a lot of factors, right? When you're in the race, you're chasing people. He was able to, he had learned the track a lot more. So he had one qualifying, like one practice qualifying, one qualifying two. So he had 3 sessions before the races. So he was a little bit more familiar with the track. The conditions were probably different as well. So he eventually went faster. And I think one big area that he was working on was how fast you can, how deep you can get into turn 1.
Yeah.
And here I actually don't really see that much of a difference in how you approach turn 1.
Yeah.
So
absolutely.
If you
so
had a second race, that would have been interesting.
Even to get more lap time, right? So it's interesting. You as the data analysis engineer working on this particular program, you're working on getting the bike better, and to kind of close this up, so we can maybe take a look at a couple of other things in the last 4 or 5 minutes. You worked the first slide here. You worked on some basics of understanding what the bike was doing to help him as a rider. Now you're looking at your qualifying versus your race, a warm up versus a race, or whatever it happened to be, and now you're seeing where some of the improvements you made to help them work on the bike, but you're also seeing rider improvement. So there's always this thing. It's never a perfect world in data, right? You're always interpreting and always trying to understand it. Pretty interesting.
Right. You're never working with a set of constants. Everything is always changing. The rider is always moving. The confidence is also building. So it's sometimes really hard. And that's why I really like having brake pressure. Because you can actually see, for example, he's slowing down. Is the slowing down due to a massive amount of engine braking, or is it just due to him just getting on the brakes earlier?
Always wanting more as a data person, right?
Right. But the advantage is you have information that drive you to ask the right questions. And usually, especially Joey, he's very analytical and he's very good at providing feedback on how the bike is behaving. So
very, very cool. So you walk through and you help fix the bike, and we, in our process here today, we analyzed and we showed here some differences. Now you would go back, and when you come back the next time, you may suggest some gearing changes, and of course some different rider techniques and some other things.
This is actually what started my my chase of the rabbit hole, going down the rabbit hole of trying to predict the rear wheel speed as a function of gearing and lean angle. So I started this entire spreadsheet on the side where I'm trying to account for tire size, lean angle, tire deformation, to see ahead of time, like what effect the gearing is going to have. But then you're starting with this entire realm of geometry, where if you're changing the gearing, you're changing the sprocket size, you're changing the swing arm angle, you're changing the rake and the trail of the bike, you're changing everything.
One thing affects everything. Yeah.
So he went to a different gearing for the warm-up, the data that we're not looking at, and he wasn't happy with it. He said that it changed the geometry of the bike, it changed how the bike was really behaving, and that was only one tooth.
Oh, wow. Yeah, amazing.
So
we have a couple of questions before we start to kind of tidy this all up. Is the gear, we're looking at gear position there in the middle of our screen. Is a gear a calculated gear, or is it an actual gear position signal from a sensor on the ECU?
It's the actual position from the gear position sensor.
Perfect. And Kyle asked the question, GPS-based lateral Gs and radius, I know channel you've tinkered with a little bit, would be interesting to apply here too, I would think, assuming that it is not affected by bike lean. It is not. We can actually use a channel that makes that work. Is that ever used for analysis? Have you ever played with radius, driven radius?
I've tried to play with it a little bit, just as a, just on the side. it would be interesting to look into it a little bit more. Yeah.
And Kyle,
especially for those bikes.
Yeah, and what Kyle adds in a little bit deeper into the question is, can he pull that corner harder in second than first with the same spot on the track by using that as another metrics of understanding where that speed is coming from?
Right, that would be really interesting. I'll try to look into that. Yeah.
Perfect. The last thing I would like to do, we're right up against the clock, but if you would like to close down Race Studio 2 and maybe just show your Race Studio 3 real quickly as we're kind of tidying this all up here at the end. I think you kind of wanted to show that.
Right. I'm going to stop sharing this screen and go to the next one. All right. All right. Let me know when you see it.
It is now up.
All right. So I'm reproducing about the same screen here in Race Studio 3, and I've corrected Joe's name also because I missed it last time. So it's about the same thing. We have the same information. I do not have the wheel speed calculation, and I do not have the lean angle due to just it being a beta version and things.
Math channels were not working quite well for you. Yeah.
So what I really like here is how, so I don't know if I did it for this one. You can actually arrange the channels by type, which I really like.
Exactly.
So here I have, all the GPS based, all the ECU based channels. So you can see that we have an IMU with the accelerometers in it. All the calculated channels, not calculated, sorry, the mode channels. We have the calculated channels that are here from the ECU. And then, two-state Race Studio 3 calculated channels. So those are the ones that I add, in my processing.
It's amazing how Race Studio 3 has the same basic look and feel as what everybody is used to, but there's just all these enhancements, the mapping and some of the different things that are just so much more powerful.
And here, I guess we could show something. So we were talking about the rate of acquisition of data. Exactly. Here I have the speed, so it's front versus minus rear, which I had the opposite on the other one. But you can actually see how coarse it is. So the default on that was 1 Hertz, I think. And so this is not working for me, and I could modify it, but I was struggling with it a little bit. It doesn't give us a lot of information because it's so coarse.
The calculation rate was so slow.
Right. You actually want to make sure that you select the right data acquisition rates.
And one of the things we talked about earlier that we promised as we kind of tidy this up now, if you go up to one of the ECU based channel, maybe one of the speed channels up higher, and if you right click on it, we'll open up a dialog box. It works the same way in Race Studio 2. We were talking about sample rates coming from, maybe you have an older ECU connection or you have a newer one. You really want to know what is that sampling rate. If it should be a little cog to gear. Click on that little cog to gear. Nope, just click right on. There you go. This dialog box opens up and it will tell you what the sampling rate the data came through from the ECU. In this case, I've actually got it pretty small on my screen right now, but is it 50? I can't see it.
Here I have a 50. Yeah.
50 on that particular channel of this ECU. That's one way you can go in real quickly and look at your sampling rates that your data may be coming through if you're looking at your own ECU based data.
That's where you set up your decimal, your unit of measure. What I really like is the value. So if you want to add, if there is like an offset, you can correct the offset here. You can also reverse the channel. So sometimes I like to overlay brake pressure and throttle on the same plot, but sometimes I like to have them like completely flipped. So that's what I would use for that. We have also the alarms. So in Race Studio 2, the alarms color the side, the channel window on the side. It just like becomes red, I think, whenever you're moving your cursor. Which
if it's high, cool. Blue if it's also lower than your low level, and something maybe we'll do another webinar a little bit deeper about it. But the alarms in Race Studio 3 have changed a little bit, where you can actually change the color of the trace out into the data, which is very powerful.
I love that. This is great. Yeah.
Perfect. I just wanted to show that dialog box where you could figure out exactly, those of you that are grabbing some ECU data and you don't know what that sampling rate was, a quick, easy way. It works in Race Studio 2 and in Race Studio 3. Okay.
And a feature that I really like that in Race Studio 2, I would always export it to Google Earth. Here you have it integrated where you can actually see the line So look in this corner of the screen. I guess we can go to track right here. And you can actually see the track. So what is
the driven line, yeah.
accuracy? Yeah. What is the accuracy? So it's a couple feet maybe.
It's sometimes better, right?
It's fairly accurate. It looks really accurate. I don't see any instances where he's going off track. So yeah, it looks like it is pretty much the actual driven line.
And we generally know that he didn't. And the other thing that's that AIM has added for Race Studio 3 that's real important is the kind of the base is Google is the imagery they use. But and you don't need to do it now, but over in that upper right corner, you see a little tile, a set of tiles, and you can go ahead and just click on that box over there.
I'm on it.
Just click on it, but don't open it. Don't change it. That will bring up a list of different background imagery that you can actually place under it. There you go. So you have a choice of, if one doesn't fit well, if the image is not quite correct with the world, they've done some stretching and stuff to get the images to work in Google, let's say, you can use a Bing map, or you can use some different maps. So that is a very powerful tool of finding a good image that works with the data. It's almost always the data. Every once in a while will have a little bit of a shift, but I have found that the problem being most often is the background image. So some of them are just depending on your Wi-Fi connection, you're using a heavy Wi-Fi load while you're doing a Zoom call, so it's going to take a little while. But anyway, cool. Yeah, it is that one happens to be just a drawing, but some of the other ones obviously are imagery. Perfect. I appreciate it. We've answered, I think, most of the questions that came up, which was kind of good. If you would unshare and let me share my screen again, and we'll kind of tidy this up, and I think we've got all the questions taken care of. Chloe did a great job of discussing a bunch of different specific motorcycle tasks, but they go across the board, and in any form of racing you have. Just the process of her engineering mind going in and digging into motorcycle data is always interesting and always applicable to any other form of motorsports. We happen to use motorcycle data today, but it's really good to learn those. We'll be able to take a look at this video later for those of you that are watching live. Those of you that are watching it later, you know about our YouTube site, or you wouldn't be watching this now, but we have 169 videos up there, and we're adding to them every week. In fact, last week, after our Tuesday webinar, if you go and visit there, I did a joint webinar that we placed up there with Racers 360 and Mazda, where we talked about some data analysis steps available on our YouTube site. Just go and visit that. This one will be up here within an hour or so, and we'll have everyone that we do here, all of these webinars go up there very, very quickly. We're a customer support company that happens to sell racing electronics, as we like to say. If you have any questions about your hardware, about your software, give us a call, 800-718-9090. We're happy to help. We are out at racetracks every single weekend, having a great time, and love to see you while we're out there as well. I know all of our staff travel a bunch. I am going to be at the Formula Drift event coming up this coming weekend up in near Seattle, Monroe, Washington. So I get out to, not as much as I have in the past with some of these other duties, but I do continually get out to races as well. So looking forward to seeing you out there, or here with a call or an email as well. What are we going to do next week? Coming webinars. This one is going to be one that a lot of people have been asking me about and chatting about. We have a host that's coming back that hasn't been with us a while. He's a very, very busy driving coach in the Ferrari Challenge world, and plus many other series. Ray Phillips is going to come back and join us. He's what he's going to talk about is, of course, it's going to have this data analysis focus to it, but we're going to do validating setup changes using racing simulator data. So what Ray has been doing is they do a lot of simulator work, and he has found where he is now using Race Studio 2. He's making those shock changes, or he's making those chassis changes, whatever they happen to be, and he's bringing it into Race Studio 2 and into the Race Studio analysis programming, and understanding how they're working. And he's found some pretty good processes and pretty good ways of doing that. And Ray's going to share those with us next week. And no doubt, because it's simulator data, he'll he'll share the data files and the profiles and all, and the math channels that he's using. So that'll be very, very good. Ray has been very popular here as a co-host, and hope you're all looking forward to seeing him next Tuesday, August 3rd. Join us. It's going to be a very, very good time. A little bit of contact information for Chloe. It's been great to have you here. We're Chloe is, again, she's out there in MotoAmerica getting lots of experience, doing lots of work. She has been telling me that she is now walking through the paddock area, and people are recognizing her from the webinars and asking her more and more AIM questions. So just a fantastic lady, and helping lots of people, and we really appreciate it. She is nice enough to give us her share her contact information here if you have any questions about what she has talked about today, any deeper stuff. Chloe, as we're kind of closing this down, is there anything else you'd like to add to close this one down?
No, thank you very much for having me, and then I'll see you for the next one.
Perfect. And it was great to have you here again. We're going to do one. She's already booked for probably about a month out. I don't have the exact weekends right now. One last thing as we're kind of closing it down, number 147. We talked about it a little bit before we started today. Why 147 as an engineer?
Oh, so 14.7 is the stoichiometric air-fuel ratio of gasoline, and yeah.
Nobody but an engineering would pick their number in that particular process, and that impresses me to no end. I
had 171 as a backup, because 17.1 is the air-fuel ratio of nitromethane, and I thought it was pretty cool. But yeah,
there's always a story behind numbers, and it's always intriguing to me. So I appreciate that one a lot. Thanks everybody for coming. I hope you had a great time. Hope you're watching these on YouTube later. Look forward to seeing everybody next week on our live version on Tuesday. Talk to you guys soon.
Thanks, Roger. Bye.
Thank you.